And let me take you through first off just a brief agenda that we'll be covering. So we're going to talk about dashboard design principles, show lots of examples, and then we'll look at what we consider 5 important steps in dashboard design. And then we'll leave time at the end for questions and answers. So as a company, Analytics has been in business since 2001 as a leading BI and digital analytics company. We've worked with over 800 customers across North America and done over 450 consulting engagements. The 2 major players that we work a lot with are Tableau and Good Data. One of the important things that we can never ignore when doing dashboard design is the ETL, the extract, transform, and load process. And it's a 3-step process of first obtaining the data from the data sources. What data do we want to grab, and how do we want to visualize that? Then converting that into a format that's suitable for visualization and BI tools. Sometimes it natively works just fine, but other times it needs to be cleaned up and modified slightly. And then, of course, we need to bring that into the BI tool or the loading it in. So as a simple example, if you look at a date system like this, where it's 2013, 10/25, or October 25th, that can be expressed in a number of different ways in a spreadsheet or a database system, etc. And so Tableau or Good Data or any BI tool needs to be aware of the structuring of that data and of those dates in order to properly render it. And I'm sure you've been aware that in some spreadsheets you could use multiple formats. So these are the kinds of things that need to be cleaned up. So dashboards have become really important because they help businesses monitor KPIs, and we think it's tremendously important that dashboards are KPI oriented. They help us better understand your customers and respond to competitive pressures much, much more quickly. And they really bolster your decision making and your ongoing planning. And so you don't have to ask the question of, on a scale of 1 to Lindsay Lohan, how bad was that decision you just made? Maybe they'll be better from now on. So dashboards should provide insight, and we think that's critical. A lot of organizations put in dashboards to produce better looking reports, but the fundamental thing we think is you need to invest in something that's going to provide new ideas, new insights, and allow you to make better decisions. It needs to fit on a single page. Otherwise, it's a report. It needs to be self-service, so the end user needs to be able to slice and dice the data to uncover new trends and do that themselves without relying on outside people. And it needs, of course, be customized for individual users, because not everybody wants to know things about certain market trends. Different people have different usage within a company. And again, it should be based on goals and objectives, and it should be KPI driven. And you need to be able to sort of, with the dashboard, ask the most fundamental thing is, what is the most important decision you make on a regular basis? That's what the dashboard needs to address. So some of the major guidelines are, make sure you place the most important part top left. Legends should be placed on the right-hand side. And don't get bogged down with too many different colors. Most systems will allow for 16 million different colors, but you really want to make sure you narrow it down to a certain color scheme throughout the dashboard so it doesn't look cluttered. And I've highlighted the word many in the next section, or the next bullet, because there's sort of a debate often of whether you should produce multiple dashboards to convey the same message, or many views in a single dashboard. We tend to favor the latter, and I know a lot of people don't. But we think it's important to allow the dashboard to be an interactive tool so that it really provides guided analytics, and that we can interact with it and get multiple views from the same dashboard. And if we look at some of the types of images that we may have to work with, one of them would be, looking at things changing over time. And when you do that, a time series chart is very good. You could also use a scatter plot or a horizon graph. Now, let me show some examples of that. This is a charting of unemployment data in the U.S., and we look at unemployment percentage and over time. And these are actually decades that we're going across time. And that's one way of showing it, but another very effective way of showing it is a scatter plot. Now, these are all the various dates across decades. If I add color to this, we can start to see which decades are performing better than others. And in fact, we can pick out specifically certain decades that we want to look at to see what was happening in those years. And you can see in the 2000s, we really have done very poorly. High unemployment rate with a lot of loss of workers in the work field. Now let me show another dashboard that shows some insight and that we've made very interactive. So this dashboard was created as a product to show leads that were captured and gained in the U.S. for a company that sells school supplies. And they wanted to know, what how many leads were they generating per state. But moreover, we produced for them some drop-down menus so that they could see not just number of leads, but other metrics as well, and allow them to drill down further and ask more iterative questions. So the map, which is the most important component, is top left, and by hovering over any state, it'll give us information about that, such as the demographics, the total number of students in the state of California, the budget we have for generating leads, the number of leads that were generated, the budget per lead, per capita leads, and then some conversion metrics as well. Number of conversions, what the conversion rate was, and so on. And we can see that for any given state. And of course, the state of California, with the largest population, will have perhaps the most leads. But we can then slice this and look at, well, what about conversion rates? How did we do across the U.S. for conversion rates? And suddenly the numbers look very, very different. California doesn't perform very well. It simply does well because it has such large population. But the areas where we're performing better are in states like Wyoming and Georgia. And we can take a look at, well, what's the total budget? What's the total budget that we have? What's the budget per lead? And now we see that in South Dakota, we've done by far the best on budget per leads. We had a very low budget, but we generated quite a few. We can also look at per capita leads. So we brought in some population metrics as well. And we can look at per capita leads that we have. And we can slice this further to take a look at, for any given state or any location, what type of schools are there in that various location. And so how does that affect our leads and our ability to do poorly or well in any given state? We also have over here, this is kind of the aha moment for this client. We looked at response time impact on conversion rate. So it basically says, if you respond to a lead within 2 hours, the chance of success is 6.46%, that you'll close that lead and make a sale. If you respond within a day, it'll be 4.67, and later than that, 3.89. Now, all this data was available to this client. It was in their big data set, but they hadn't noticed it, they hadn't seen it until we created this visualization, and suddenly it became very apparent. Now, obviously, anecdotally, this might be true, but this is information they can charge down to the sales teams and really, in a challenging way, say, here's what we need to do better. And of course, if we click on any one of these states, those numbers will update and reflect specifically to the state that we're now looking at. So now we can see what it looks like for the state of Georgia. And their performance is extremely high, for responding within 2 hours. And all of the other parts of the dashboard updates tell us leads generated, generation budget, number of leads converted, etc. And also here we have some updates of week over week and year over year increases or decreases in leads. So the next type of thing, if we're looking at where something is, using a map is very, very effective. If we were to look at showing highest and lowest values, we think using a bar chart makes most sense. And a bar chart in this case is horizontal, but quite often they're vertical. And that's not often a good idea. It's difficult to read these numbers and these names when it's placed that way. So instead we suggest you turn it around and make it horizontal. Pie charts are kind of one of my pet peeves, and it's probably one of the worst things to include in dashboards and things like dials and thermometers and so on. They really are useless visualizations that don't provide a lot of value, and they're kind of confusing often. And indeed, here it's very difficult to assess what percentage it is and even which one is larger than the others. And it's even worse when organizations do this in 3D. So instead, we suggest using a bar chart in this case. And now you can very clearly see this blue is the greatest in the area of shoes, and it's about 42%. And you wouldn't be able to see that very easily if it wasn't done in a bar chart. Pie charts are useful and probably the only place in maps. So here we now can see in the state of Texas approximately what percentage is blue and so on. But the size of the dot also reflects maybe volume of population or volume of something that we want to convey. So there it can be useful. Color is a tremendous aid when looking at trends and patterns and so on. If I would ask you here, look for the 9s, it's really very, very difficult to do. But if we add color to it, those 9s just kind of pop right off the screen. And accountants have known about color for a long time. So if you look at a simple cross chart like this, cross-tab chart, without color, it's hard to see right away where the losses and gains are. But if we add color to it, suddenly those numbers jump out at us. And a heat map like this shows it in another way, very visual and takes up less space. It's exactly the same data that's being conveyed here in a heat map. The larger the box, the greater the revenue, and the darker green rather than red, the more profitable. We can also save space by combining various elements like these legends and have them combined like that. So if we take volumes and volumes of data, this is a much better way to visualize that data than having reams and reams of columns and rows. And that allows us to start isolating out and picking out certain areas that are outliers. If this is the number of tickets issued and this is the dollar amounts per ticket, then we can see these ones must be very high cost tickets, since there aren't that many, but it's quite far over on the right-hand side of the scale. So that allows us to start evaluating things much better and see things in a more visual way. Horizon graphs are kind of a new thing, but they were developed by a company called Panopticon in Sweden, and it was a way of visualizing lots of data for over time frames and comparing them. And it's very often used for stocks, how stocks are performing. Now, it may look very confusing when you first see that, but this is how it's built. We start with a normal line chart, and we color the positives, in this case, in blue, and the negative values in red. And this is sort of then the baseline, the zero line. And then we take slices, maybe at 2% or 5%, whatever they might be, consistent slices up and down. And as we get above the first slice, we give it a darker blue color or a darker red color. The next step is to bring that dark blue down to the baseline but you can still see where that slice sort of came from up here. And we do the same thing with the reds. And the final step is to mirror that so that the red gets put up top. But we still know that's a negative thing. But now the level of space that each row takes up is far, far less than here. And so we can very quickly take a look at and understand the areas here are, of course, red, dark red, so this is bad. And we can start seeing trends and how these stocks are performing. Let me show another example of that. Here are some of these employment figures as well. And if we look at employment data with a line dashboard, and we look at the various states, and I'm going to violate my own claim here of not scrolling. There's just too much data on this one, and I wanted to show this. You can see it's over time from 79 to 2009, and these are then employment figures. I can hover over any spot. These data sets are all live, but it is very difficult and confusing to try to interpret these lines because they just all kind of look the same. So instead, we can put it in a horizon chart, and now the data becomes much more vivid when it pops up for us. We're just going to let that render. And here now we can quickly start seeing trends, and this is obviously a very negative area, positive here for some of these other states, which is interesting during the same time period, but it's very quickly we can start to visualize that data. So we talked a lot about designs and we've looked at examples. Let's take a look at some of the theory, because we think it's really important when you create a dashboard that you consider who the audience is, what they're trying to solve, what the issues are they're having. And you're really starting with a blank canvas when you create a dashboard. And I'm sure it won't be terribly surprising for you to know that if you had two people both tasked with the same charge to produce a dashboard for specific business visualization, they'll come up with very, very different ideas of what it should look like. And frankly, probably one of them is much, much better than the other. So we have a 5-step approach of how we design dashboards. So the first thing we would talk about is what are the one or more metrics of measures your end users need to focus on. Secondly, we take a look at how will the end users want to break down the key numbers and those dimensions. Thirdly, what will be the primary interaction mechanisms in the dashboard? And then how much data are you visualizing in terms of measures, metrics, and dimensions? It could be millions and millions of rows, or maybe it's very, very little. And then finally, how familiar is your end user with data visualization tools? So if we use the two examples that we looked at, one was the leads dashboard, which was this one right here, the leads dashboard, and then the other one on population. If we use those, or unemployment, pardon me, if we use those two as the choices here, and let's go through this process. So the first step is what are the one or two metrics or measures that your end users need to be focused on? Well, these core numbers really become part of every aspect of the dashboard. So for the leads dashboard, it's leads and it's conversions. For the unemployment, it's unemployment rate. Maybe it's pretty obvious. So how will these end users want to break down the key numbers? What kind of dimensions do they need to look at? Because these dimensions will determine the visualization approach used in the various dashboard elements and how many elements we actually need. So for the leads dashboard, the key pieces are state, it's region, so those geographical pieces, and then it's product lines, time periods, and response time. For the unemployment one, the breakdowns are really state and year. For the third one, what will be the primary interaction of the entire dashboard? And this main interaction really will determine what kind of visualization that you plan to use. And there should really only be one or two primary types of interactions per dashboard. So for the leads one, it's geography. That's become sort of an obvious one as we're dealing with a map. And that provides that interaction around that map. And for the unemployment one, it could be both time and geography, sort of provide some interactivity centered around a map. And they also provide a chart that can display change over time, such as that horizon graph. So then we have to ask ourselves, well, how much data do we have to visualize, and how can we slice that up? And is it possible to slice it all up into measures, metrics, and dimensions? And so the volume of that data helps determine what visualization works best for the data. So for the leads dashboard, there's really a small number of rows of data, but there's a large variety of dimensions allowing us to ask those iterative questions and allow us to make the dashboard very interactive. For the unemployment one, there's a large data set, hundreds of thousands, millions and millions of rows. So we have a lot of information, and with that dense visualization, it's good to use something like a horizon chart or a scatter plot. And then finally, how familiar are the end users with the visualization tools? The more familiar they tend to be, the less guided your dashboard needs to be. But if they aren't that familiar, you need to provide them with sort of step-by-step, element-to-element interactions to allow them to drill down and guide them through the process. So to create an effective dashboard, data cleansing, of course, is important. But you need to also make sure you're picking the right visualizations and provide self-service analysis and reporting so the end users are empowered. They're the ones who understand their data. They then should therefore have the tools available to them to create the best visualizations possible and make that interactive. And so then you need to be able to ask sort of that most important, what's the most important decision you make on a regular basis? And the dashboard needs to address that and answer that question. And so we recommend using the 5-step dashboard design. So let's have some questions and answers. And there have been some questions, and let me start by addressing them. One of the questions is, if we have a flat file, can you change it into OLAP cubes and then design dashboards? It's rarely the best approach, but we can certainly assist doing that, and we have done that. Flat files tend to be very unstructured data, and an OLAP cube, by nature, wants it to be very structured. So there are some challenges to it, but it can be done absolutely. A question, do you offer dashboarding optimization? Yeah, I mean, as a company, we offer a lot of services other than just providing these tools and providing training. And we do that, and we do that very well. But we also provide the extract, transform, and load. We help clients structure that data. But then we also help clients bring in data sets of various sorts. Tableau and Good Data are good at bringing in many, but not all data sets. So some may have to be developed through APIs, or there are lots of third-party organizations we work with that can help us bring in data sets that aren't natively available through some of these tools. We also help clients bring in demographical data and then marry all of that into the system. Another question here is, does Unalytics use more than analytic data? Can you pull CRM, email, etc.? Absolutely we can. And you know, some CRM tools are natively supported by these products, such as Salesforce. Others are not. Sometimes we have to bring data into sort of a common denominator, such as Excel. And you know, that can be an automated process, so it can work very, very well. But there are, of course, thousands of applications out there, and these companies haven't developed connectors for all of them, and maybe never will for some. So we help by using third-party tools to bring in things like CRM and email and social media and analytics, web analytics, data, etc. Question is, do you prefer Good Data or Tableau? Well, we do offer both products, and as a company, we felt it was prudent for us to offer both because they're really very different. Tableau is software that you install on your own computers, and Good Data is a hosted service, a cloud-based offering. We think that from a visualization point of view, it's tough to beat Tableau. They're very, very strong there. But complex connectivity and more choices for connectivity is available in good data. If you're particularly connecting to cloud-based systems, good data offers a very rich environment for that. So it really depends on the situation. And I can say also that Tableau just last Thursday announced some new cloud-based services. So I don't think there's any doubt that they will long-term offer a very hosted service as well. A question here, can we go over the 5 steps one more time? I'm not going to do that right now. We're actually going to offer a webinar in the very near future which will go over the 5 steps in much, much more detail. So we'll leave that for another day, and I'm not going to spend time doing that right now. That looks like all the questions that we have right now. So I want to thank all of you for your time and your interest. And certainly if you have any more questions or any other comments, please feel free to contact us. Thank you very much.